2 days of calculus word problems, okay? We introduced the concept of taking a derivative with respect to time, okay? When we do this, we are going to find how things, quantities are changing at a moment in time, like areas, volumes, distances, okay? All what we're going to look at with these calculus word problems. And we are going to take formulas that we've been using in geometry and past math classes, and we will be taking the derivative of these formulas, like the area of a rectangle. We're going to see, hey, how is the area changing at a specific moment in time if the rectangle is growing in its length or its width? And you will be taking the derivative with respect to time of a formula like this. And you have to be comfortable saying, okay, the derivative of A would just be dA dt. You'd have to be comfortable with the product rule here. The derivative of L would be dL dt W plus the derivative of W dW dt L. So we're using the product rule there. We have to take the derivative of areas of circles. So the derivative of pi r squared. Well, derivative of A, dA dt, pi r squared. Pi is not a variable. It is a constant, so you don't have to use the product rule. You just have to take the derivative of r squared. Think about it. It's just like the derivatives of x squareds, only you're going to need the d blank dt afterwards. We're going to have the 2 come down. It's just 2 pi r dr dt. Okay? And this is just a couple of examples. We need these formula, these 6, you need to know them. Like, I'm not going to give you these for a question that I'm going to ask. Perimeter of a rectangle, twice the length plus twice the width. Circumference of a circle, 2 pi r. Pythagorean theorem is what we're going to use to find changes in distances. We'll say the diagonal distance squared is equal to the horizontal distance squared plus the vertical distance squared. We're going to use SOHCAHTOA. So we need to be comfortable with like the sine of an angle being equal to the relationship of the opposite side. The opposite sides typically are vertical sides, so I'm going to put y over our diagonal length, our hypotenuse. Instead of putting h, I'm going to put d. And just so you're comfortable and so you're ready to do this, go ahead and take the derivative of the circumference of a circle. You should get just dc dt equals 2 pi dr dt. Take the derivative of the Pythagorean theorem. Two capital D, d capital D dt. 2x dx dt. 2y dy dt. Oh my goodness, they all have 2's. I could cancel out each of these 2's. So you just have d dt, x dx dt, y dy dt. Okay? And you can kind of understand what this is telling me. Like, the change in the circumference of the circle depends on the change in the radius of a circle times this constant 2 pi. Change in an area of a circle. Okay, this is how quickly the area of a circle is changing. Well, if I know the radius and I know how quickly the radius is changing, multiply that by 2 pi and you get the rate at which the area is changing. Or you could think about it, 2 pi r is the circumference of the circle. So if I know the circumference of the circle and I know how quickly the radius is changing, that's going to be the way that the area is changing. Think about it, you're just going to be adding just a little bit of a circle. The circle's just increasing, okay? This one over here typically gives some students some problems. I'm just going to do the left side. I'm not going to do the quotient rule on the right side because we'll find that usually we'll have a simpler right side than this quotient. But what would be the derivative of sine of theta? Cosine theta, but that's not it. Yes, d theta dt. Theta is a variable. So cos theta d theta dt. These 6 formula, including that the diameter of a circle is equal to twice the radius, these need to be known to you. So if you need to remember the area of a circle formula, the circumference of a circle formula, make sure you have those down. The remaining formula, I'm not going to write volume of a cube. I'm going to say surface area of a sphere. These will be given to you, but it will be your responsibility to be able to take the derivative of them. So the volume of a sphere, you do not have to know that the volume is 4/3 pi r cubed. The surface area of a sphere, you do not have to know that the surface area, I'm going to use SA, is 4 pi r squared. Volume of a cylinder, you do not have to know that it's a pi r squared h. Volume of a cone, you do not have to know that it's 1/3 pi r squared h. But it is your responsibility to be able to take the derivative of these. So, take the derivative of the volume of a sphere. Good. Check yours with a neighbor. You're good. It's correct. Just the 4/3 times the 3, 4. Okay, so you got 4/3 pi times 3r squared. We know that 4/3 and pi are just constants. This 3 can be multiplied by the 4/3 to get us 4 pi r squared, because I'm subtracting 1 using the power rule, dr dt. Now these two down here, the volume of a cylinder and the volume of a cone, if we were to keep these as they were, you'd have to use the product rule. This would be a long, messy derivative. We're not going to do it. I'm going to show you when we do these problems, typically we can remove one of these variables and not have to use the product rule. Okay? But if we didn't remove it, we'd have to use the product rule. But all I'm telling you is that it's your responsibility for these 4. They will be given to you. It's your responsibility to take the derivative of them. Okay? Now, what else is important when we're doing these calculus word problems is the translation of statements into calculus notation, into information we can use. You know, in word problems, typically teachers say, write everything down that's given. Well, you'll be given stuff like this, like the radius of a circle is growing at 3 inches per second. But you're going to say, that's not r equals 3. It is the rate at which the radius is growing. That would be dr dt is 3. It's a growth rate. dr, change in r, dt, change in time. This is how fast the radius is changing at a specific moment in time. They're telling us it's 3. The perimeter of a rectangle is shrinking. Well, that's the rate of change of the perimeter. That's dp dt. Since it's shrinking, what is the rate of growth? Negative. Okay. Area of a circle, dA dt, is growing at 5 squared centimeters per hour. Horizontal distance, typically we'll say that a horizontal distance is an x distance, a horizontal distance. So this is dx dt. Since it's decreasing, it's -2. We won't really worry about units until the end, but something to help us understand units is that when we have units to the first power, that's typically for like lengths or distances. If you have units squared, that's typically telling you that we're talking about areas or surface areas. And if you have units cubed, we'll have volumes. Okay? When we come back for Genius Hour, we are going to be ready to tackle some calculus word problems. So, knowing that we can take derivatives of formula, knowing that we can translate rates of change using calculus notation, d blank dt, we're ready to start, okay? All of these problems we're going to do today and next class will just progressively get a little trickier, harder, okay? So we're talking about increasing levels of difficulty as we go. So this is the easiest one. The easiest one because the formula is given to you. All you need to do is write down the formula, translate the other information, and then just like your quiz problem, you're going to take the derivative of this thing with respect to t, plug in your information, and solve. So I'm told that the volume of water in a container is given by this. I'm going to just go ahead and simplify this. Where h is the height of the water. Now, from the rest of the problem, we need to do some translations. We're told that the water level rises at 2 feet per minute. We are wondering what rate is the volume increasing when the height of the water is 3. Okay, at what rate is the volume increasing? That would be dV dt, and that's what I'm trying to find. That's what's given to me in green. When the height of the water is 3, h is 3. That's the blue guy. The water level rises at 2 feet per minute. Sometimes it's important to kind of see what we're given. We're given h and v in our formula. H is the height of the water. We're told that the water level is rising. That's how quickly the height of the water is changing. So I am told with the yellow guy that dH dt is 2. Okay, and that's what makes these calculus word problems. We're not just given all the information and we just take the derivative and solve. We have to do the translation. Now we are ready to find dV dt. Well, the only way I can get dV dt is to take the derivative of this with respect to t. I'm actually going to change this height of the water as 3 to a 1, just so that the calculations are a little bit easier. Okay, now the derivative of v would be dv dt. 40h cubed, 120 h squared dh dt. 10 times h to the fourth, that'd be 40 h cubed dh dt. Okay, writing down the information, taking a derivative. Now we just need to plug in our information and solve. I'm trying to find dV dt. I'm given h and dH dt. Go ahead and you guys do it while I do it. So dV dt, I got is 160, 240 minus 80. That would be a change in a volume, so we're going to use cubic units. Cubic feet per minute is how quickly the volume of the water is changing. Okay? It's not bad, right? Get your formula, get your translated statements, take the derivative and solve. Let's do the next one. A spherical hot air balloon is being inflated. If air is blown into the balloon at a rate of 2 cubic feet per second, how fast is the radius of the balloon changing when the radius is 3? So you will be given the volume of a sphere formula. This will be given to you. So this is why this is not that hard. This is 4/3 pi r cubed. You guys do the translations of the other information from the word problem. So the one that's tricky is air is being blown into the balloon at a rate of 2 cubic feet per second. Well, the units give you kind of a helpful hint here. It's cubic units. So that is dV dt. That's volume. How fast is the radius of the balloon changing? That's what we're trying to find, dr dt, when r is 3. We have all that information down. We're ready to take the derivative of our formula so that we get something with dr dt, plug in our information, and solve. Let's go ahead and do that. Four-thirds pi, just a constant. Derivative of r cubed, 3r squared. The 3 can be multiplied by the 4/3 to just give me 4 pi r squared dr dt. dV dt is 2. R is 3. Trying to solve for dr dt. Radius is just a distance, it's just a length, so it's going to be units to the first power. Make sure you have the pi in your denominator. I'm dividing by pi, dividing by 36 pi, really, and I get this. Okay, not that bad. Okay, this would be a little bit more difficult because I would not give you the formula for an area of a square. Why don't you guys write down that as well as the other information and go ahead and tackle this guy. I think I need to give you more information. when the length is half a foot. Okay, if you think the area of a square is length times width, that might hurt you than if you did just like a side length being squared, or L squared, or W squared, since it's a square. Length and the width are the same. These side lengths are shrinking, so in this case that's ds dt, that's minus 2. If you used L squared, you'd have dl dt is negative 2. If you use L times W, you'd have to use the product rule for your derivative. So best not to use that, side length being squared. How fast is the area? That's dA dt when the length is 1/2 of a foot. If I took the derivative of A equals S squared, I'd have dA dt equals 2S ds dt. And I get dA dt is negative 2. It's an area, so it'd be in squared units. And it's shrinking, so the area, change in the area is going to be negative. Okay. Next question. Upping the level of difficulty, we're going to be dealing with multiple formulas. Talking about the surface area of a sphere growing at a rate of 10. This would be squared meters per second. So fix that in your notes. How fast is the volume of the sphere growing when the radius of the sphere is 5 meters? You'd be given that the surface area of a sphere is 4 pi r squared. You would be given that the volume of a sphere is 4/3 pi r cubed. You were told that the surface area of the sphere is growing at a rate of 10 squared meters per second. So write what that is translated using calculus notation. You're asked how fast is the volume increasing when the radius is 5. So I wrote dSA, because my formula uses SA, could have just used A or something and it'd be dA dt, but I wrote dSA dt is 10, dV dt I'm trying to find, R is 5. Well, since I'm trying to find dV dt, I might as well take the derivative of V. Let's see, do I need dSA, do I need the SA formula at all? I get dV dt equals 4/3 pi is just a constant. The derivative of r cubed 3r squared. So this would be 4 pi r squared dr dt. And I know r is 5. Okay. So that's 25 times 4. So this would be 100 pi dr dt. But I am not given information about how quickly the radius is changing. This is an unknown to me right now. But guess what? We were given information about how quickly the surface area is growing. We're going to have to use this piece of information and this formula to find dr dt, and then we'll plug it into this dv dt formula. So go ahead and do that. Let's see if we can all get the correct answer. Okay, we should get 25. It's a change in a volume, so it's in cubic units. Next one, upping in our level of difficulty because I would not give you the formula for this question. You would have to write it down yourself. So, write down the formula as well as the information that you think you're going to need. The question is, the circle's diameter is growing at a rate of 3 centimeters per second. How fast is its area growing when its radius is 6 centimeters? Just like any word problem, good first step is to write down what you are given. What do you have? This is write down what you are given and write down the formula you think you're going to need. So we're talking about the area of a circle, so we need pi r squared. We're given the diameter is growing at 3 centimeters per second. We're trying to find dA dt, how fast the area is growing. We're given that r is 6. I got a equals pi r squared, but what also will help me is knowing that twice my radius gives me my diameter. Because if I took the derivative of the a equals pi r squared, First, let's make sure we get the derivative down correctly. And I plug in r, which is 6. I still don't know what dr dt is. But I'm given information about dd dt. Taking the derivative of this guy would be able to help me find dr dt. I get dr dt is just 3/2. dA dt will equal 12 pi times 3/2. That is 18 pi. It's an area, so it'd be squared units. Next one, very similar, but again, it's with spheres, so I would give you some formula. The volume of a sphere is 4/3 pi r cubed. Question is, at what rate is the diameter increasing at the instant the radius of the sphere is 3 centimeters? Go ahead and try that. This is very similar to the last one. Another one where I'm going to use d equals 2r. Trying to find d dt. I'm given dv dt. And r is 3. I can take the derivative of both of them to start. Shows me that I need to find dr dt to find dd dt. There's other ways to do this, but I'll just stick to this way. Again, I've taken the derivative of 4/3 pi r cubed before. That's 4 pi r squared dr dt. Oh. Okay. So yeah, r is 3, dv dt is 3 pi. Okay, so 4 pi times 9 dr dt. Divide by 36. It's 1/12. Dividing by the pi's cancel. That goes here. And I should get 1/6 as my answer. Say length, so it'd be centimeters per second. Okay. Next one, same type of question. Multiple things are going on. Again, I am not going to give you formula, so this is why this is a little bit more difficult. We are told at some point the rate that the circumference of a circle is growing is 4 times the rate at which the area is growing. What is the length of the radius at that point? Not many numbers given to us here. You, my friends, need to know the formula for the circumference of a circle and the area of a circle. Those are the two you are going to be using. You also need to translate this statement. The rate that the circumference is growing is 4 times the rate at which the area is growing. At some point, the rate at which the circumference is growing is 4 times the rate at which the area is growing. This is what we should have down. dc dt equals 4 dA dt. I'm trying to find R. A lot of things we can do here, but we are definitely going to be using the derivatives of both of these formulas. So why don't we just do that? Take the derivative of both of these. Now, multiple things you can do. You can either work with the dA dt or the dc dt. Depending on what you choose, will lead you down the path to get the right answer. I'm going to just decide to replace dc dt with 4 dA dt. And I'll solve for, I'm just going to leave it like that. And I can either solve for dr dt or I can solve for dA dt. Because it looks like I can solve for one of these and substitute it in here. So I can just divide both sides by a 4, and I get an expression for dA dt in terms of dr dt. So I'm going to take this and plug it in for dA dt. And go from there. So why don't you guys finish off, find what R is. It looks like we should get an answer of 1/4. I replace dA dt with pi over 2 dr dt. I can divide both sides by dr dt. dr dt's are gone. Divide both sides by pi. Pi's are gone. To get rid of the 2, I would divide both sides by 2. I'd have 1 over 2 divided by 2, or times 1/2, and that's how I'll get 1/4. Okay? Next guy. Talking about a cylindrical tank losing water at a rate of 5 cubic centimeters per minute. How fast is the height of the water changing if the radius of the tank is 5 feet? Well, you would be told, you'd be given, you don't have to have this memorized, though it is an easy one, that the volume of a cylinder is pi r squared h. Write down all the other information that's given to you, but then pause. Don't go further. The translation of cubic centimeters per minute, that's a volume, a change in the volume. How fast is the height of the water changing? You should make that translation. That's dH dt in this case, since we are given an h. The radius of the tank is 5. All right. Pause. Just watch what I do here. Don't do it, though. Don't copy this down. For every other problem, up until this one, we would get to this step, and we would take the derivative. Okay? Don't do this. Now, for this guy, I get dV dt equals, I have 2 variables, which means I need to use the product rule. Watch what this will end up looking like. 2 pi r dr dt h plus dH dt times pi r squared. I got dr dt, I have a dH dt, I got r, I got h. We're like, yeah, I can plug in r is 5, trying to find dH dt. I'm not given h, and I'm not given dr dt. It's like, man, they didn't give me enough information in the question. They actually did, because I know what dr dt is, and I know, since I know dr dt, h won't matter. Okay, but it appears that it's like completely missing. I don't know what this is, it's not given to me. I don't know what that is, it's not given to me. Okay? Now, we could do this problem this way, by taking the derivative just like we've done for all the other problems. And if you guys can figure out what this is, then you'll be fine. And you can figure out what it is. What is it? Discuss with your neighbors. What's dr dt for this cylinder? What do you think, Mr. Mendez? Why is it 0? Because the cylinder's radius doesn't change. So if you think of dr dt being the change of the radius, well, the cylinder's radius is always the same. Now, notice this is not the easiest concept to just pick up out of the blue, that this radius is 5. It's always going to be 5. This is a great looking cylinder, okay? I am not going to want you guys to do this problem this way. Because once you plug in 0 for dr dt, you realize you don't need to worry about h because this is just 0. And we'll just have that, okay? Instead, I want you to approach this a different way. And it comes up to this statement up here. Constant values can be plugged into formula. Yes, I have r equals 5, but r will always equal 5 for this cylinder. This is what I call a fixed value. It is always true. All of the other situations that we had with our spheres growing, the radius is definitely changing. Okay, when we had circles growing, radius is changing. Nothing is always going to be a certain value. Since this is always true, since this is fixed, since the radius of my cylinder is always 5, yes, the volume of my cylinder is pi r squared h, and that's the volume just any cylinder. For my cylinder, for this problem, I'm going to say the volume of this cylinder, I can change this formula to pi times 25h. Now, since I changed it to 25 pi h, when I take the derivative now, I don't have to use the product rule. I'm not going to get a dr dt. I have a very simple formula whose derivative is very simple, and this is an easier way to get my answer. Yep, turns out, didn't even know, don't even have to know what h is. I know what dv dt is. I can solve for dh dt. This is a height, so it's in units to the first power. Okay, for the remaining problems we're going to do, we are going to have fixed values. And this will help us tremendously make something that's kind of complicated something a lot easier. Constant values or fixed values can be plugged into formula to make a more complicated formula that has a product, a simpler formula whose derivative is easy to work with. And you don't have to kind of figure out, oh yeah, dr dt's got to be 0 because the radius of the cylinder is never changing. Okay? We are going to want to do this for the remainder of our problems next class as well. It's a very, very important thing to make these problems a lot easier to do. Okay, so next problem. A rectangle's height is growing by 2 inches per second. Its length is 4 inches. At what rate is the area of the rectangle changing? Well, we know since it's a rectangle, I need a length and a width, or a length and a height. You're given how quickly the height is growing. You're told L is 4. What rate is the area changing? Well, again, just like the previous problems, not the one that we just did, this would be the step to take the derivative of the formula. But what I'm telling you is if you just read and thought about the situation a little bit more carefully, you know that one of these values is always going to be a certain value. And yes, the area of a rectangle is a length times a height, but you can change the formula to be the area of this rectangle. Okay, you guys do this problem. So before you take the derivative, change this question so that we're talking about the area of this specific rectangle. You should get an answer of 8 after all is said and done. The length is always 4 for this rectangle. It appears the length is not changing. Change your formula into an area formula for this specific rectangle. You don't have to worry about using the product rule. You do not have to do anything fancy. You will take the derivative now. You will plug in dH dt, and you'll get your answer. It's an area, so it's in squared units. Okay. Might have to change a couple words here. Conical pile of dirt is growing at a rate of 10 cubic feet per second. The radius of the pile is always 3 times the size of its height. Your notes might be wrong, so change it. How quickly is the height of the pile changing when the height is 5 feet? Okay, you will be told, and let's think about this situation. We have kind of like a situation where we have a pile of dirt, that's a cone, and like dirt is being added onto this pile. Okay, so as dirt's being added, the height and the radius change. Okay, does that make sense? Kind of like a conveyor belt throwing dirt on top of this cone. The height is going to grow, but the dirt's going to fall down, and it's also going to make the radius grow. Okay? The volume of a cone would be given to you. It's 1/3 pi r squared h. Now let's write down the other information given to us. It's growing at a rate of 10 cubic feet per second. That's dV dt. We get 3h is r. How quickly is the height of the pile changing? That's dH dt equals what when h is 5? Okay. Is h always going to be 5? Discuss with your neighbors. Will the height of this conical pile of dirt always be 5? No is the correct answer. As dirt is getting poured onto this conical pile, it's growing in its height. It's growing in its radius. So I cannot plug in 5. We want to, because we just did it on the previous questions, but I can't in this situation. But I do know something that is always true. What is always true? 3H equals R. This, my friends, is a fixed relationship. Now, I can plug fixed values in. I can also plug in fixed relationships. And I could use this and take the derivative of this and take the derivative of this. But if I took the derivative of this right as it stands, I'd have to use the product rule. It's going to be messy. And we'd have to throw in, after taking the derivative of that, a bunch of dH dt's and dr dt's and stuff like that. But instead of using the product rule, I could say that the volume of my dirt pile, this specific dirt pile, is 1/3 pi times 3h squared h. I'm trying to find dH dt. Why not just use h's? And since this is fixed, since this is always true, this is true for the volume of my dirt pile. You guys go the rest of the way. I get 2/45 pi feet per second. You can write 25 is 5 times 5. Cancel one of the 5s and the 10 to a 2. The other 5 cancels, multiplies by the 9 to get us 45 times the pi, 2/45 pi.